guys, this is lesson 5.3, solving multi-step inequalities. For this lesson, you've actually learned everything you need to know, and so it's basically going to be practicing keeping your inequality sign straight and learning just a few little quirks that might come up. So I'm going to work through some of the book examples on page 298. The first example says, write and solve an inequality to find the sales Mrs. Jones needs if she earns a monthly salary of $2,000. So that would be our y-intercept typically. Plus a 10% commission on her sales. So for everything she sells, that'll be our variable because how many she sells varies. We're going to sell a 10% commission. So 10% is 0.10. Her goal is to make at least means she wants more than that, but at least means it would be okay if it equaled that. At least $4,000 per month. And so we have our equation and we want to know what sales does she need to meet her goals. So what is that minimum number of sales that she needs? All right, so I'm looking at this equation. I always want to work further away from the x. I want to get rid of this clutter out here. I'm going to subtract 2,000 from each side because it's 2,000 plus 0.1 times x. So the multiplication is there, but the addition, 2,000 plus, is out on the side. So I don't want to divide or multiply by 2,000. I want to actually subtract that. Okay, subtraction does not flip your sign. Only when you multiply or divide by a negative. Subtraction is fine. So we're going to go ahead and do that math. And I'm going to end up with 0.10x is greater than or equal to 2,000. And then now I have multiplication and I need to undo the multiplication. So I'm going to divide by 0.1 and 2,000 divided by 0.1 is going to be 20,000. X is greater than or equal to 20,000. And notice I never divided or multiplied by a negative, and so I don't need to flip my sign at all. So she needs to sell 20,000. What is she selling? It doesn't tell us, does it? Commission on her sales. Whatever it is she's selling, she needs to sell, she needs to sell $20,000 worth of her sales because her commission is on the dollars and not on each item. So cool. All right, example 2. We have this problem, negative 11y minus 13 is greater than 42. And we need to graph the solution on a number line. So first thing I want to do is take care of the clutter. It's out here, remember, away from the y. And so minus 13, I'm going to add 13. I am not dividing or multiplying by negative, so I don't have to worry about anything here. I have negative 11y happens to be greater than 55. Nice. Now I want to deal with this multiplication. The opposite of multiplication is division. That will get those guys to cancel to get y by itself. And I am dividing by negative 11. I hope red lights just started flashing because whenever I multiply or divide by a negative, I need to change the sense of my sign or I won't get a true answer. So I have y is less than 55 divided by negative 11 is negative 5. Y is less than negative 5. I'm going to graph that on a number line. Put my negative 5. I need an open circle because I don't have or equal to, so it will never equal negative 5. My line can be named y, and y is going to be less than, so I'm going to show my arrow going less than. Okay. Number 2. I've got an equation going on here. I've got 4 times 3t minus 5 plus 7 times, oh, no times, plus 7 is greater than or equal to 8t plus 3. I probably mentioned that I'm on page 299. If I didn't, if you want to follow along, that's where I am. All right, first thing I'm going to do is go ahead. I've got t's here and t's here. I need to get them together, and so I need to free these guys from their prison of these parentheses. So I'm going to use the distributive property. I get 12t minus 20 plus 7 is greater than or equal to 8t plus 3. Now I can try to get my like things together. So I think what I'll do is go ahead and add these two things together so I don't have them just being all messy. Minus 13 is greater than or equal to 8t. So I haven't really done anything except to just sort of simplify things. I want to get my numbers together and my t's together so I can choose which I want to do first. There's a bunch of things I could choose. Whoops, that is not correct. In order to get this 8t to go to the other side, I'm going to subtract it because that makes this one cancel. Make a 0. 0 plus 3 on that side is just going to be 3. I have not divided or multiplied by a negative, so I'm just keeping my sign the same. 12 and negative 8 is positive 4t, and keep that minus 13. I want to get those numbers together, so I'm actually going to add 13. And I have 4t is greater than or equal to 16. And 4t is multiplication. I can undo that by dividing by 4 to get t by itself. I must do that on both sides. And I will get t is greater than or equal to 16 divided by 4 is 4. So I did not divide or multiply by a negative, and I did not have to change my sign. I do want to put that on a number line. So it will look like this. This is my 4. I'm going to call this number line t. I need a closed circle. And t happens to be greater than or equal to 4. All right. Number 5. I have 9. Okay, I'm actually going to go to the B part of this. Oh no, I'm going to do the A. I'm going to do 5. Okay, this is 5A. Both of these problems are special. 9t minus 5 times 5. Whoops. Minus 5 times t minus 5. T minus 5 is less than or equal to 4 times t minus 3. So I need to kind of unravel this and get these t's freed up from their parentheses. So I'm going to be using the distributive property here and here, here and here. So let's unravel this. 9t, and this is a negative, so I'm going to let that negative stay with the 5. So I'm going to say minus 5t plus 25, negative 5 times negative 5. Keeping my sign the same, I'm not doing anything to multiply or divide by negative. 4 times t, and 4 times negative 3 is negative 12. All right, things I can combine. 9t and negative 5t actually give me 4t. plus 25. I can begin to see something odd going here. 4t plus 25 really can't compare much to 4t minus 12. If I'm adding 25 to something, it's not going to be ever less than that same something taking away 12. Does that make sense? But let's keep going just for the sake of going. If I want to get my t's together, I'm going to subtract 4t, and then I notice that I have 25 is less than or equal to negative 12. 25 is not less than or equal to negative 12. And so I am not going to have any solution to this. We will say no solution. Nothing works in this equation. It is a null set that looks like that as a symbol for that. Okay, the B equation here is also interesting. 3 times 4m plus 6 is less than or equal to 42 plus 6 times 2m minus 4. And again, I might want to use the distributive property to free up those m's from the parentheses so that I can get everything combined it needs to be. So I have 12m plus 18 is less than or equal to 42 plus 12m minus 24. Nice. I can combine my 42 and my negative 24 over here. 42 minus 24 gives me 18. Keeping my sign, 12m plus 18. Look at that. There, I have the same things on both sides, right? So if I subtract 12m from both sides, it cancels. I have 0 and 0. And then if I subtract 18 from both sides, that cancels, and I have 0 and 0, and I end up with 0 is less than or equal to 0, which is a true statement, just a little strange, right? So whenever I have a true statement like this, all values of m will make this inequality true, and so all real numbers are solutions. All right, that's probably the end of my examples. Most of what you're working on here is these multi-step inequalities. The big thing you need to remember is if you divide or multiply, could have said multiply or divide, by a what? Negative, then I need to change the sense of the sign or flip the sign around. Okay, that'll keep your sentence true. Other than that, everything is the same as what you have learned previously this year and in years past. So you're just solving these equations. Watch out for these weird ones. If you get a true statement like 0 is less than 0, then all real numbers are solutions. And if you get an untrue statement like 25 is less than or equal to negative 12, which it never is, you will say no solution and use the null set sign like that. There is going to be a practice assignment in Alex, so go ahead and try that and see what you can do.